Good morning, everyone. We will finish chapter 24 today. Last time we introduced the implementation of the array list and linked list. Array list is implemented using array. When you insert an element into the array, you have to shift the elements to the right, so leave a space to insert this element. And when you delete an element, and you have to shift it to the left to fill in the space. So because this is internally, it is an array. And the linked list, it is implemented using the linked list data structure. So every element is wrapped in a node. The nodes are linked together. So when you insert something and you just create a node and then put all the links together. So that is the for the linked list. So the time complexity for this data structures, the linked list is very efficient if you have frequent operations to insert and delete at the beginning of the list. So you're going to choose the linked list. The time complexity is order 1. So that's a constant time. It is not dependent on the size of your list. Doesn't matter how big your list is, it's always order 1. It's a constant time. For the array list, and that's order n when you insert and delete at the beginning of the list. So that's the key difference. In most cases, you are going to use array list. Array list is in general more efficient, except in this situations, you're going to work at the beginning of the list to do insertion and deletion at the beginning of the list. All right, so now we're going to look at the implementation of the stacks and queues and priority queues. So here, let's look at the stacks and queues. All right, so a stack is a data structure. It's very important in computer science. And in computer science, in our operating system, the execution environment is centered on the stack. It's a stack, stack, stack. So when you invoke a method and the information about the method is pushed onto the execution stack. So that's the stack. Stack is the data structure, is the last in, first out. So the last thing, and you like in the execution environment, and the last method you called, it's going to finish, and then it's the caller is going to be on the top. So this is the way, and the execution stack is organized. So in the we can look at this data structure right here in this animation. So if you're going to push things, the stack is right now is empty. So this is the operation. It's called push, is to add things into the stack. So that's called a push. Okay. All right. So push. So we're going to push it, and so this is now 34 is on top of the stack. So let's look at 11. So you push 11. 11 is on top of the stack, and 55 and 45. 45. 45 is on the top of the stack, and the 55 and 55. Oh, okay. 455. Okay, it's on top of the stack. So now let's look at the 15. So 15 is on top of the stack. All right. So when you use peek, you're not going to remove anything. You just see, hey, who is on the top of the stack? So the peek is the top element is 15. And so now if you do a pop, so it's remove the first element on the stack. That's the top, the last one you added. So this is 15. So 15 is removed, and this is 455 is removed. So it's a stack. It's a data structure stack. The data is last in, first out. All right, so let's look at this, the queue. Queue is going to be, the data structure is the first in, first out. So commonly, and we call this operations in queue. So you put things into the queue, it's in queue. So we're gonna add 72. Okay, 72 in queue. So it's put the number into the queue. All right, and here let's have this is 13. So 13 is in the queue. So when you remove the element from the queue, it's called a DQ. The operations DQ, and from the beginning, so this is 30 is now removed, and this 2 is removed. All right, so this is how it works. It's the queue. So these are the data structures, and for storing data, and the way we operate in data has this rule is for the stack is the last in, first out. For the queue is first in, first out. So we're gonna have this implementation for this data structures. In the Java API, we already have the class called a stack, but that's not what we're implemented, because that stack is a subtype of the a vector. It's a subtype of actually going to the list. It inherits all the unnecessary methods into the stack class. So the best way to implement it, we're going to use this approach called using composition rather than using inheritance. So using inheritance, you would implement something like this. Stack is a subtype of array list. So this is the last in, first out. So very naturally, we're going to use the array list for this operation. It's very efficient. When you push, it's ordered one time, and pop is ordered one time, peek is ordered one time. And so this is here, it's using inheritance to make this stack is a subtype of array list. That's not good implementation. So the best way to do it is to using composition. Composition is this here. Array list contains generic, or the generic stack contains the array list. So this is here, is using composition. We actually already implement generic stack in chapter 19. So when we introduce the generics, we have this example in the chapter. So now let's look at the queue. So let's call this generic queue. We're going to do this implementation using composition to make generic. This queue contains linked list. So internally, we're going to store data for generic queue using a linked list. Right. So this is the UML diagram. Now for generic queue, it contains internal data is stored in a linked list, and the operations are enqueue, dequeue, and the get size. So how many are in the queue? All right, so this is really simple. You see how this simple it is? And we write the code to implement it. So this is the code to implement. This is the class is generic queue. All right, and this is the generic queue. It doesn't extend anything or implement anything, but internally, and we use this linked list. This new java.util.linked list. So this is the right now it's empty linked list. So when you do enqueue, so how you do this enqueue, you're gonna have this list. Look, this is the list here, and you're going to do. So you can just use add method. That's add to the end. Or there's another one here you can use is using the offer, but we can just use add. This should be sufficient. You can do this add. So enqueue is add, and dequeue is you're going to remove the last one. So remove the last one here, and so you can use add, and also here you can use enqueue, use add last. So this is the same. It's for this dequeue. Now this is here something it's important here. Look at this, remove last. Okay, now when you dequeue is remove first. Okay, so please remove first. Okay, is this correct? No, you have to say list dot remove first. So this we're using the list here, linked list, to store this. All right, so here is the implementation for generic queue, and now this is the test code for using generic stack and for using. So this is the generic stack, and this is for using generic queue. See how we use this is the data, the operations. Here's push, okay, for stack, and for the queue is enqueue, and for the stack pop, so to remove it, and so this is the pop, and for the queue is dequeue. So this is all. All right, so this is the so what's the complexity? It's super efficient. It's all of one-time complexity for this stack is push pop all of one, and the peak is also all of one, and for the queue, enqueue is all of one, and dequeue is all of one time. So think about it. If you come back here for the generic queue, instead of using the list, linked list, so you change this to array list. All right. Okay, will the program work? Yes, the program will work just fine, but it's not efficient. Okay, so the program, of course, this has to be changed. This is like, you have to, when you do a remove here something, you're going to remove at this index is 0. So this is the for the array list. So, all right, so you can do this, implement it, and using array list, but it's not efficient. Because when you do this remove at the beginning of the array list, it's going to order in time. So that's why we change this to linked list. And to linked list, it's more efficient. It's super efficient. It's all at one time. See, look, we have so many data structures. You use the data structures in the right application. All right, and next, let's look at the implementation of the priority queue. All right, so here we're going to look at this. All right, so what is a priority queue? Priority queue is that you have the elements, and it can be any objects. So you assign priority on the elements, and the highest priority is removed from the queue first. It's always removed first. So the priority queue is like in the emergency room. So you go to emergency room, and depends on your condition, and you'll be served based on your condition. So this is the priority. And the for the queue, it's like you check out in the grocery store, you go to the checkout line, so that's a checkout line. So this is the checkout line. It's using the queue data structure, and to simulate this, the process of the cashier checkout. And the priority queue, you can use it to simulate the hospital emergency room service. All right, so now we're going to store data in the priority queue, and priority queue, we're going to provide the operations also like enqueue and dequeue. That's by convention, so we use this terms. And so we enqueue, we're going to put the elements into the priority queue and remove dequeue and remove it from priority queue. All right, so how do we implement a priority queue? So we're going to implement it using our data structure we already learned. It's a heap data structure. So the heap data structure here for storing data internally in a priority queue. So this is the priority queue right here, the constructor. And we're going to construct a priority queue. And so how you could compare the elements? So by default and using their natural order. And you can specify a comparator. So this is another way to construct a priority queue. In queue, DQ, get size. All right, so here, how are you going to implement it? So this is my priority queue. So this is the in the Java API, there's a priority queue already. So we now have to call this as differently. Just call it my priority queue. All right, so internally we're using heap. So now remember the heap is data structure, and then we use it in the heap sort. And this is the it's a complete binary tree with the order. So the root is always the one is the highest priority. So it's the largest element. So we always remove the one from the root. All right, so here, and this is my priority queue. So how do you implement this? Now, this constructor here with a specified comparator, and that is that's actually easy here. You're gonna you're gonna use this new heap here. The heap has this. Okay, so using this to create the heap. Okay, and so for this this one here, you can just use this heap is new heap. It's using the NOI constructor. So this is using the default comparator. All right, so this in queue, and this is going to be heap dot add new object. So you're going to add a new object into this. So DQ is going to, you're going to return this removed element. So this, I think it's called remove. So this is the name of the method. So the get size, I think there's a heap get size is something like heap dot get size. All right, well, check it out here, get the answer. So this is the answer. Yes, everything's right. Okay. And you can reset it and try it over again. So this is all here now. You can fill in all the contents. And now we're gonna write a test program using my priority queue. So here I'm gonna test priority queue, and this is the I'm gonna have the patients. Okay, so let's create a class patient, and patient has this natural order here. Let's do this. We're gonna implement the comparable interface for the patient. All right. So how do you do a compare to? So they compare with the priority. So the priority. So here, this dot priority and subtract O dot priority. So here, each patient, you have the name and the priority. So the name and the priority. And so here, this is the one. All right, so here's the name and the priority, name and the priority. So this is a new patient, and the name is Tim, and the priority is 5. All right, so now we're gonna create the priority queue, and for this, so you can have this is new my priority queue, and this is empty priority queue using the NOI using this the NOI constructor, and this is the natural order. So this is going to be the natural orders, these comparable interface to compare to. All right, so here is enqueue patient 1, enqueue patient 2, enqueue patient 3, and now let's go with priority queue dot enqueue patient 4. And now we're going to use this while loop to get all the patients. So while priority queue dot get size is greater than zero, so we have more in the priority queue. So we're going to do a dequeue. So we're going to dequeue. So this is here. All right. So now you're going to see this is what you have here. It's the priority. See the Cindy is 7. So this is 7, 5, 2, 1. All right. Okay, now just hypothetically, we do something differently. Let me just run this code, just make sure this is compiled correctly and run. All right, so everything runs fine. So this is good, runs fine. Let's change this this one here. I'm going to change it. Instead of using this the priority is right here as defined here using the compare to. So here's the compare the priority. I'm just do it by their name in alphabetic order of their name. All right, see if we can do this. There's a small problem here is I can't get this name out. This is private. So what I can do is here is to add a get method. I'm going to add get string get name. All right, get name. It's going to return name. Okay, so I just added this one here, just to oops. I didn't do anything. So true. Okay, that's fine. All right. So you see what we have here is we have a get name here. So get name for this patient. All right. So now I'm going to change this my priority queue using a different criteria to compare patients. So just by their name. So I'm going to have this. This is P1, P2. All right. So we know it's going to be patient, and so here is because this is the elements are patient here, P1, P2. So is going to use P1 dot get name, okay, dot compare to P2 dot get name. Okay, so the priority is now determined by the name. So the name, in alphabetic order, and so this is going to be the highest. Is going to be, it should be T, Tim, and then J. So let's see then, see this is going to work this way. Okay, I got to give it a try. Write the code, see how it works. Okay, we got a problem here. Is this compared to it's something missing here. Is compare. Oh, I missed the this one right here. So let's go down here. I'm going to move this here. All right, see here, this parenthesis is matching this parenthesis. I missed this parenthesis for this one here, so need one more. Okay, one more parenthesis. And now let's give it a try. Compile. Okay, Tim Jamal, Cindy, and Chandra. Okay, see that's see how easy to write the code. Now you see all these things with this interface and with the lambda expression. So how simple you can just change one line of code and you get this quickly done now. All right, any questions? All right, so I think that's the end of this chapter. So I'm going to now move to the look at the programming projects. So here, let's look at these two programming projects together. So I'm going to look at the first one, this one here. We're going to implement set operations in my list. So these are the set operations. Add all, it's like union, and remove all, difference, and retain all, its intersection. And I have another retain all, it's the same. What is going on here? Returns. So that's a spelling here. Why? Okay, we're gonna fix this. So this is the this is wrong. Okay, we're gonna look at this. This is the use this template. Use the template to implement these methods. So for a hint on this program, and see this right here. I'm going to do this is to look at here is go. Okay. All right. So this is the template for exercise 2401. So here we have this. Okay. This is the this one here. We just get a copy from the book. So this is the code, and you already given to you. You read and digest it, and so this is test code. And this is just copy from the book, the my array list class here we have, and this is my list interface. So my list interface here, this is here. We need to write this my list interface. So let's do a copy and paste on this. All right, so here is this is the my list interface. So my list interface, and I'm gonna go down to my list interface. So here's my list interface right here. Let's go get the answer, everything. You need to go with a copy. So we need to implement this contains all, add all, remove all, retain all. And so, and this, all these methods right here. So this is here. So add all, remove all, retain all, and this is apparently something is not right. Okay. So here is contains all, add all, remove all, retain all. Okay. And then, yeah, this 4 here. And this is 2 array, and there's another 2 array here. Okay. So this is 2 array. So this is 2 array here. So here is so this one here is okay. Yeah, I think this is something I'm gonna fix this, but now you know what you need to do is all this methods here, left for exercise. All right, so I'm gonna copy and paste everything here. All right, let's do this here. First thing we need to do is we're gonna go to here. Okay, we're gonna copy everything from here to right here. All right, so here, this is write your code, and now go to copy and paste to write your code right here. All right, I'm going to show you how to do one now. It's here is add all. All right, so how do you do add all? Okay, this is the my. Where's my list? This is my. Oh, I need to get rid of this here. So my list extends this right here in my list interface, so we can implement this add all. So contains all, add all, remove all, retain all, and 2 array. And there's another 2 array here. Okay. All right, so this is contains. I'm gonna do contains all, and this is add all, and this is remove all. All right, how do you do this add all? All right, I'm gonna just write a code here for you here. It's let's do this here. Add all. Add everything in this here, the collection, in this argument collection C into this collection. Okay. So you can write this code here. It's it is 4. Okay. So everything in this C. So here is the is C here. Okay. This collection C. So is extends E. So anything subtype of this E. So this is fine. E in C. So everything here. And you're going to do this dot at E, right? This dot at E. Okay, it looks really simple, but this is something you have to look at it. Is what are you going to return? So this it could return false if there's nothing added. But actually for this case, for the list, in case of list, if this C is not empty, you always add something into the list. So if C is empty, so like this here, so you can write something like this is going to return, and C is empty. So, but we need to make sure we have this method is empty already here. Is I think we're going to look at, yeah, is empty here. So return is empty. So if it's empty, and that's going to be false. If it's not empty, it's going to be true. So like this, return. Okay. All right. So work on the rest and remove all and return all. And this is a 2 array. So look at this 2 array. And let's look at the next. Okay. This one. All right, for this, and implement a doubly linked list. All right, a doubly linked list. I'm going to implement a doubly linked list. In the book, the linked list is singly linked list. Okay, it only has next, next, next. But in the double linked list, we have previous, previous, previous. All right, so here, look at the node class. You have this element, you have next, you have previous. All right, so here's my linked list class used in live example 24.5 is a one-way link directional linked list that enables one-way traversal of the list. Modify the node class to add a new data field named previous to refer to the previous node in the list as follows. So this is the previous. Okay, and use this template to implement a new class named two-way linked list that use a double linked list to store the elements. All right, so here, look at this and also the hint as well. So I'm going to show you this now first. So this is the template you're going to use, and see here, I'm going to show you all the way down here and see this is the my list. It's a copy from the book, and this is the two-way linked list, and you're going to implement. There's a lot of things already here. The only small part you need to write this right here. If you go down, you're going to see, and this is you're going to write your code, and write your code here, write your code. Okay, let's see, it's right here, and write your code. All right, I'm going to give you, I think I want you to read it first, and then I'm going to give you some hint and give you some implementations and give you as example, you can work on this. But first, I want you to take a look of this program project, and then we will talk about next class. All right, but now let's go back to the previous chapter, the program project. All right, do you have any questions for this programming project in chapter 23? So I'm going to go down to this and show you here what you need to do. This is.
Yeah, I have a quick question about it.
All right, just a second. I'm going to open this up here. And this is due tonight. And here, I'm going to show you right here now. This is the one. Okay. All right, so here. And use the template at this and to implement clone and equals method in the heap class. So here is the one. All right, and so okay, so this one you have, yeah. All right, so look at this template and the main method. So you have this heap created and from this array, and here and get size and this equals, and you remove this from heap one, so heap one size and heap one two size, and see this here, and this is equals here. And so here there's a clone here, so they clone from heap one and to heap two. Okay, so this is what you need to write is this the clone and the equals. So look, when you have the clone, this is go top is implements the clonable interface. It's here. So we're going to look at the clone and to perform a deep copy and for this. All right, so what's your question? Shalom?
So I just wanted to ask for the comparator. We don't need to implement it under the clone method again, right?
No. When you
Since
clone, so here when you clone, look at the heap. You heap the this is the heap right here. So yes, you have to clone all this here. This is let's just a second here. I'm going to quickly. No, you don't have to do the this. You just have to do a deep clone on the internal data structure that the array list is used for the heap. So you have to deep clone on the array list. Yeah.
so why don't you have to clone for the comparator? Is it because it extends E already?
This one here, because you don't change. Yeah, I think I can make if you want. Yes, you could. Yeah, I think I did. The test program here I did not have anything to test on the comparator. So the comparator, and you do a shadow copy on the comparator, that's fine. So yeah, so I was focusing on more on this the contents here, the in the heap. Okay, I see a point here. Do you need to and also you can do this. but for this one, it is not. It's because it's just simply a reference. So it really doesn't matter because it's not another level of data structure. It's just a simple reference. You just shadow copy of this comparator. Yeah. So the comparator, yeah, it's a shadow copy of the comparator. Yeah.
Thank you.
So you don't need to do any deep copy of the comparator. Comparator is not another layer of the data there.
Thank you.
Sure. Any questions? Okay. So feel free to leave if you don't have questions. If you have questions, you can stay with me. Okay. All right. I'm going to stop recording now.